Chapter 10 Space Missions Introduction. Man has always been curious about unknown places, and he has always been eager to expand the horizons of his knowledge by exploring the unknown world. Man not only has curiosity about the unknown places on the earth, but also about the unknown places around the earth. He must have had deep curiosity about the space and the many twinkling stars in the dark sky. He must have had dreams to fly to the space and must have been working for that. In this chapter, we are going to study about the space explorations done by man to quench his thirst of knowledge. In the previous grade, we have studied that the portion of the Earth's atmosphere and the portion beyond that, which can be seen in the form of a roof by our eyes while standing on the Earth, is called the sky. Whereas the continuous empty space between the spheres, like that of planets and stars, etc. in the sky, is called space. It may contain gases and dust particles. Numerous star clusters have formed in space. Out of all the different groups of stars, our solar system consists of the Sun, 8 planets and their satellites, dwarf planets, comets, and asteroids. Do you remember what is meant by satellite? The celestial bodies that revolve around a planet without independently revolving around the Sun are called satellites. Moon is the only natural satellite of the Earth. Man has stepped onto the moon. Also, he has sent some spacecrafts for collecting information about the unknown facts in the universe. Come then, let us now study how this has become possible. Space missions. In the later half of the 20th century, substantial developments in technology, especially space technology, happened. This resulted in the development of spacecrafts, making space voyage possible. Since then, more than 1,000 artificial satellites have been placed into orbits around the Earth. Additionally, space missions have been undertaken for close observation of various objects in our solar system. We shall learn about various space missions in this chapter. The space missions can be classified into 2 categories. In one type of mission, the objective is to put artificial satellites in orbits around the Earth for research and various other useful applications. The objective of the second type of mission is to send the spacecraft to outer space for close observations and understanding of the objects in solar system or even outside the solar system. Do you know? The first person to go into space in a spacecraft was Yuri Gagarin of the then USSR. He orbited the Earth in 1961. The first person to step on the moon in 1969 was Neil Armstrong of USA. Rakesh Sharma of India orbited the Earth in 1984 in a Russian spacecraft. Kalpana Chawla and Sunita Williams of Indian origin also participated in space explorations through missions organized by NASA, that is, National Aeronautics and Space Administration of USA. In the previous grade, we have already studied about the various types of telescopes orbiting around the Earth. Can you recall them? Yeah, right. Some of the important telescopes which are active in space include optical telescope, gamma-ray telescope, X-ray telescope, telescope receiving ultraviolet rays, infrared telescope, microwave telescope, radio wave telescope, and the telescope receiving the gravitational waves. Come, let us now answer a few more questions. We all make use of cell phones nowadays. It has made our lives simpler. We can easily contact a person staying at a distance. But have you ever wondered, where does the signal in your cell phone come from? Where from does it come to the mobile towers? We all love to watch TV. We are even able to see the live telecast of the matches being played in other countries. How does this become possible? Where does the signal to the TV come from? While reading the news, you might have seen photographs showing the position of monsoon clouds over the country in the newspaper. How are these images obtained? All these become possible with the help of satellites. As we have already learned that, along with the natural satellite, there are many artificial satellites orbiting around the Earth. An artificial satellite is launched into space for a special purpose through space missions. Come then, let us now study the need and importance of space missions in the coming part of this chapter. Need and importance of space missions. Many artificial satellites have been launched in space, due to which the world has become a global village. Today, we can contact a person in any part of the world within a second. The information about worldwide events can be gathered sitting at home. Internet is of very much importance in today's world. Due to Internet, every information is available at our fingertips. It has become possible to get advance alerts about natural calamities and take proper precautions. During war, it is possible to get information about the actions of the enemy through aerial surveillance using satellites. It is also possible to explore the fossil reserves and minerals in the Earth. Thus, there are unlimited applications of space missions. Today, space technology is an inevitable part of the development of a nation. Come, let us now know about artificial satellites. Artificial satellite. In our earlier grades, we have learnt about natural satellites. An astronomical object orbiting the Earth or any other planet is called a natural satellite. The Moon is the only natural satellite of the Earth. Some other planets in the solar system have more than one natural satellite. Similarly, if a man-made object revolves around the Earth or any other planet in a fixed orbit, it is called an artificial satellite. The first artificial satellite, Sputnik, was sent to space by Soviet Union in 1957. Today, more than 1,000 satellites are orbiting the Earth. Satellites work on solar energy. So, solar photovoltaic panels are attached on both sides of these satellites like wings. Instruments are installed in the satellites to receive the signals from the Earth as well as to transmit signals to the Earth. Satellites have various other types of instruments depending on their functions. One such satellite is shown here. Signals transmitted from the Earth to the satellite and from the satellite to a mobile tower and mobile phone are also shown. These satellites are sent into space to perform various functions. Depending on their functions, satellites are classified into different categories such as INSAT, that is, Indian National Satellite, GSAT, that is, Geosynchronous Satellite, IRNSS, that is, Indian Regional Navigation Satellite System, IRS, that is Indian Remote Sensing Satellite, GSLV, that is Geosynchronous Satellite Launch Vehicle, and PSLV, that is Polar Satellite Launch Vehicle. Let us now study about some types of satellites and their functions, as well as the names of their Indian satellite series and their launch vehicles. The weather satellite studies and gives predictions of the weather. The Indian satellite series INSAT and GSAT are used for weather satellites, and the launcher used for them is GSLV. The communication satellites establish communication between different locations in the world through the use of specific waves. INSAT and GSAT series satellites are used for this purpose and are launched by GSLV. Telecasting of television programs is done with the help of broadcast satellites. Broadcast satellites are of the INSAT and GSAT series and are launched by GSLV. The function of navigational satellite is to fix the location of any place on the surface of the Earth in terms of its very precise latitude and longitude. Navigational satellites are of the IRNSS series and are launched by PSLV. The military satellite is used to collect information for security aspects. The Earth observation satellite is used for the study of forests, deserts, oceans, polar ice on the surface of the Earth, as well as for exploration and management of natural resources. This satellite is also used for observation and guidance in case of natural calamities like floods and earthquakes. This satellite comes under the series IRS and is launched by PSLV. Now that we have studied the different types of satellites and their functions, we shall proceed further to learn about the orbits of artificial satellites. Orbits of artificial satellites. There are many artificial satellites revolving around the Earth, but all of them do not revolve in similar orbits. The height of the satellite's orbit from the surface of the Earth, the circular or elliptical nature of the orbit, and whether the orbit shall be parallel to equator or making some angle with it. All these depend upon the function of the satellite. The satellite is taken to that height using a satellite launcher to put the satellite in its proper orbit at a specific height above the surface of the Earth. Then the satellite is given a specific velocity known as the critical velocity, that is VC, in a tangential direction to the orbit. Then the satellite starts revolving around the Earth. Do you know how can the critical velocity be determined? Come, let us know about it. If a satellite of mass m is revolving around the Earth in an orbit of height h with speed vc, then a centripetal force mvc square upon r acts on it. Here, r is the orbital radius of the satellite from the center of the Earth. This centripetal force is provided by the gravity of the Earth. Therefore, centripetal force is equal to gravitational force between the Earth and the satellite. This equation can be written as mvc square upon r plus h equals to capital G into capital M into small m upon r plus h the whole square. Therefore, vc square is equal to capital G into capital M upon r plus h. Therefore, vc equals to square root of capital G into capital M upon r plus h. This is equation 1. Here, G is the gravitational constant, which is equal to 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. M is mass of the earth, that is equal to 6 into 10 raised to 24 kilograms. R is radius of the earth and its value is 6.4 into 10 raised to 6 meters, which is equal to 6,400 kilometers. H is the height of the satellite above Earth's surface, and R plus H is the radius of the orbit of satellite. From this equation, it can be seen that the critical velocity does not depend on the mass of the satellite. As the height of the satellite's orbit from the Earth's surface increases, the critical velocity decreases. Depending on the height of the satellite's orbit above the Earth's surface, the orbits of the satellites are classified into 3 categories. Come, let us study about them. High Earth orbits. Height from the Earth's surface greater than 35,780 kilometers. If the height of the satellite's orbit above the Earth's surface is greater than or equal to 35,780 kilometers, the orbit is called high Earth orbit. A satellite revolving in an orbit 35,780 kilometers above the Earth's surface will take around 24 hours to complete one revolution. We know that the Earth also takes almost 24 hours for one revolution. If the satellite is revolving in an orbit parallel to the equator, the time of rotation of the Earth around itself, and that for the satellite to revolve around the Earth being the same, the satellite will appear to be stationary with respect to the Earth. If a passenger is sitting in one vehicle and another vehicle is moving parallel to him with equal velocity, then that vehicle appears to be stationary to that passenger. The same happens here too. These satellites are therefore called geosynchronous satellites. Since these satellites are stationary with reference to the Earth, they can observe a specific portion of the Earth continuously. Therefore, they are used in applications like meteorology and for carrying signals for telephone, television, radio, etc. Medium Earth orbit. Height above the Earth's surface 2,000 kilometers to 35,780 kilometers. If the height of the satellite's orbit above the Earth's surface is between 2,000 kilometers and 35,780 kilometers, the orbits are called medium Earth orbits. Geostationary satellites orbit above the equator. These are therefore not useful in the study of polar regions. For this purpose, elliptical medium Earth orbits passing over the polar region are used. These orbits are called polar orbits. In these orbits, the satellites complete one revolution in 2 to 24 hours. Some of these satellites revolve in circular orbits at a height of about 20,200 kilometers above the Earth's surface. Global positioning satellites revolve in such orbits. Low Earth orbits. Height above the Earth's surface 180 kilometers to 2,000 kilometers. If the height of the satellite's orbit above the Earth's surface is between 180 kilometers and 2,000 kilometers, the orbits are called low Earth orbits. The satellites used for scientific experiments and atmospheric studies revolve in low Earth orbits. Depending on the height of their orbits, they complete one revolution in about 90 minutes. International Space Station and Hubble telescope also revolve in low Earth orbits. Do you know? A group of students from COEP, that is, College of Engineering, Pune, made a small satellite and sent it into space through ISRO in 2016. The name of the satellite is SWAYAM and it weighs around 1 kilogram. It is orbiting the Earth at a height of 515 kilometers. The main objective of the satellite was to provide point-to-point messaging services using a special method. Come, let us now solve some numerical examples. Satellite launch vehicles. Satellites are placed in their specific orbits by using satellite launch vehicles. The functioning of the satellite launch vehicle is based on Newton's third law of motion. A specific type of fuel is used in the launch vehicle. The gas produced due to combustion of the fuel expands due to its high temperature and is expelled forcefully through the nozzles at the rear side of the launch vehicle. As a reaction of this, a thrust acts on the vehicle. This thrust drives the vehicle high into the space. The structure of the launch vehicle is decided by the weight of the satellite and the type of the orbit of the satellite. The fuel of the vehicle also depends on these factors. The fuel forms a major portion of the total weight of the launch vehicle. Thus, the vehicle has to carry a large weight of the fuel with it. To overcome this problem, launch vehicles with more than one stage are used. Due to this, the weight of the vehicle can be reduced step by step after its launching. For example, consider a launch vehicle having two stages. For launching the vehicle, the fuel and engine in the first stage are used. This imparts a specific velocity to the vehicle and takes it to a certain height. Once the fuel in this first stage is exhausted, the empty fuel tank and the engine are detached from the main body of the vehicle and fall either into a sea or on an unpopulated land. As the fuel in the first stage is exhausted, the fuel in the second stage is ignited. The vehicle now contains only one stage, that is the second stage. The weight now being reduced, the vehicle can move with higher speed. Almost all vehicles are made of either two or more stages. The structure of a Polar Satellite Launch Vehicle, that is PSLV, developed by ISRO of India is shown here. The lowermost part contains the engine using solid fuel, which provides the initial thrust. The PSLV contains 4 stages containing solid and liquid fuel systems alternately. That means the first stage uses the solid fuel, the second stage uses liquid fuel, the third stage again uses solid fuel, and the fourth stage uses the liquid fuel. The topmost part of the PSLV has a place to carry the satellite. The launch vehicles can be used only once and thus they are costly. Thus, USA has developed a space shuttle. Let us know about a space shuttle in brief. A space shuttle takes off vertically like a rocket, revolves around the Earth like a satellite, and lands back on the Earth like an aeroplane, after which it is repolished for reuse. A space shuttle has 3 main parts. 1. Reusable Orbiter Vehicle, that is OV. 2. The Expendable External Tank, that is EET. And 3. Reusable Solid Rocket Booster, that is SRB. This whole assembly is fired at a time. Within the journey of first 45 kilometers, fuel of the booster rockets gets over. They get detached automatically and start coming back towards the Earth. parachutes attached to them open up and control their speed. They slowly come down on the earth and land in the sea. Naval staff present there takes them out, and after minor repairs, they are reused. The space shuttle keeps going ahead with the help of liquid fuel rockets. After some time, the space shuttle attains the desired height. By this time, the liquid fuel tank has become empty, so it gets detached from the space shuttle, and while coming towards the Earth, it burns off due to friction. Then the space shuttle revolves around the Earth. If necessary, it is set in a proper orbit using 2 additional rocket engines. Later, the upper part of the space shuttle opens up for the release of the satellite by robotic arms. Once the satellite is launched in its orbit, the space shuttle returns to Earth. This means that, except the fuel tank, the space shuttle can be reused in multiple launches. Always remember, a type of firecracker known as rocket used in Diwali is also a sort of launcher. In this rocket, the fuel is ignited using a fuse and the rocket is projected into the sky just like a satellite launcher. Similarly, if a balloon is blown and released with its end open, the air in the balloon is forcefully ejected and the balloon is pushed in the opposite direction. This can be explained using Newton's third law of motion. Come, let us now proceed further to study about the space missions away from the Earth. Space missions away from the Earth. Our lives have become more and more enriched with the help of artificial satellites. We have learned that telescopes aboard artificial satellites are used to gather information about the universe. Similarly, some space missions are used to gain further knowledge about the universe. In these missions, spacecrafts are sent to the objects in the solar system nearby Earth to observe them more closely. New information has been obtained from such missions, and it is helping us to understand the creation and evolution of our solar system. For such missions, the spacecrafts must escape the Earth's gravitational force to travel into the outer space. To achieve this, the initial velocity of the moving object must be greater than the escape velocity of the Earth. Escape velocity on a planet can be obtained using the formula V escape is equal to square root of 2 into capital G into capital M upon capital R. Here, capital G is the gravitational constant and its value is 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. Capital M is mass of the planet, that is Earth, which is equal to 6 into 10 raised to 24 kilograms. Capital R is the radius of the planet, that is Earth, which is equal to 6.4 into 10 raised to 6 meters. Therefore, V escape is equal to square root of 2 into 6.67 into 10 raised to minus 11 into 6 into 10 raised to 24 divided by 6.4 into 10 raised to 6, which is equal to 11.18 into 10 raised to 3 meters per second. Therefore, V escape is equal to 11.18 kilometers per second. Thus, if a spacecraft is to escape the Earth's gravitational force to travel to the outer space, it must have minimum velocity of 11.2 kilometers per second. Do you know? The astronomical object closest to us is the Moon. Light takes 1 second to reach from Moon to the Earth. It means that if we travel with the speed of light, it will take 1 second to reach the Moon. However, since a spacecraft travels at a much slower speed, it takes longer time to reach the Moon. The shortest time taken by a spacecraft to reach the Moon so far is 8 hours and 36 minutes. Come then, let us study about the space missions on the Moon in the next part of the chapter. Moon missions. Man had always been curious about the Moon. We can observe the Moon even with our naked eyes. Since the Moon is the closest astronomical object to us, the first space missions to objects in the solar system were the missions to the Moon. Such missions have so far been executed by USA, Soviet Union, European countries, China, Japan, and India. The spacecrafts in the Luna series sent by Soviet Union reached near the Moon. Luna 2, launched in 1959, was the first such craft. After that, till 1975, 15 spacecrafts made chemical analysis of the Moon and also measured its gravity, density, and radiations. The last 4 crafts even landed on the Moon and brought the samples of stones on the Moon for analysis in laboratories. All these missions were unmanned. America also executed moon missions from 1962 to 1972. The speciality of these missions was that some of these were manned missions. In July 1969, Neil Armstrong became the first human to step on the Moon. In 2008, Indian Space Research Organization, that is ISRO, successfully launched Chandrayaan-1 and placed it into an orbit around the Moon. It sent useful information to the Earth for about a year. The most important discovery made during the mission was the presence of water on the surface of the Moon. India was the first country to discover this. Come, let us study about the missions on the planet nearest to the Earth. Mars missions. Other than the Moon, the astronomical object nearest to the Earth is Mars. Many nations send spacecrafts to Mars. Mars mission is difficult and almost half the missions to Mars were unsuccessful. However, ISRO's performance in this mission is remarkable and we all should appreciate it and must be proud of it. The spacecraft Mangalyaan, made by ISRO using minimum expenses, was launched in November 2013 and was placed into orbit around Mars in September 2014. The Mangalyaan obtained very useful information about the surface of the Mars and the atmosphere around it. After knowing about the Moon and the Mars missions, let us now know about some astronauts of Indian origin who have traveled into space. Let us first know about Rakesh Sharma. Rakesh Sharma was the first Indian to travel to space. He went into space along with 2 Russian astronauts under the joint Indo-USSR space program. He stayed in space for 8 days. You must have surely heard the name of Kalpana Chawla. Kalpana Chawla obtained her engineering degree in aeronautics from Punjab and in 1988 obtained her doctorate from the University of Colorado. She was in space for 336 hours during the research mission. While returning to Earth from space on 1st February 2003, the Columbia spacecraft exploded and Kalpana perished. There is one more Indian astronaut named Sunita Williams who has made us proud. Sunita Williams traveled in Space Shuttle Discovery in 2006 to the International Space Station. She worked for 29 hours outside the space station. She created a record by staying for 192 days in space. Now that we have learnt about some astronauts as well as the Moon and the Mars missions in the earlier part, let us now study about the missions to other planets. Missions to other planets. Apart from the missions to Moon and Mars, many missions have been executed to study other planets too. In some of these missions, the spacecrafts orbited the planets, some landed on the planets, and some just passed near the planet and observed them. Additionally, spacecrafts have been sent to observe asteroids and comets. These spacecrafts have successfully collected some dust and stones from the asteroids and brought them back on the Earth. We are getting very useful information from all these missions, which have proved useful in clarifying our concepts about the origin and evolution of the solar system. Come, let us now study how India has made progress in the space technology. India and space technology. India has launched many satellites into space and also has made remarkable progress in the science and technology of launch vehicles. Various types of launch vehicles have been developed to put satellites having a weight of up to 2,500 kilograms into all types of orbits. PSLV and GSLV are two such important launchers. The scientific and technological feats achieved by India in this field have significantly contributed to the national and social development. The INSAT and GSAT satellite series is actively working in the field of telecommunication, television broadcasting, and meteorological services. Availability of television, telephone, and internet services all over the nation has become possible due to these satellites only. EduSat satellite in this series is used specially in the field of education. IRS satellite series is working for monitoring and management of natural resources and disaster management. The IRNSS satellite series has been established to exactly locate the position of any place on the Earth's surface in terms of its precise latitude and longitude. Come, let us now know about a great scientist who has done an immense work in the Indian space technology. Introduction to scientists. Vikram Sarabhai is considered as the father of Indian space program. His efforts led to the foundation of the Physical Research Laboratory, that is PRL, at Ahmedabad. In 1962, Indian government contributed Indian National Committee for Space Research under his chairmanship, and the first satellite launch center was established at Thumba in 1963. The launching of India's first satellite Aryabhatta into the space was the result of his efforts. He played an important role in the establishment of Indian Space Research Organization, that is ISRO. Till now, we have studied that numerous satellites have been launched into space. But do all these satellites remain functional forever? The satellites may become non-functional due to some reason. What happens when the satellite becomes non-functional? Also, there are chances of the launcher getting detached during launching of the satellite. What happens in such cases? Come, let us know about this in the next part. Space debris and its management. We know that artificial satellites revolve around the Earth. In addition to artificial satellites, some other objects are also revolving around the Earth. It includes non-functional satellites, parts of the launcher detached during launching, and debris generated due to collisions of satellites with other satellites or any other object in space. According to one estimation made in 2016, there are about 2 crore pieces which are more than 1 centimeter in length revolving around the Earth. All this is nothing but the debris in space. This debris can be harmful to artificial satellites. It can collide with these satellites or spacecrafts and damage them. This debris is increasing day by day. Soon it will become difficult to launch new spacecrafts. It is therefore very essential to manage the debris. Some studies and experiments are being done with this in view. Hope that soon we will have a solution to this problem and the future satellites and spacecrafts will not be in danger anymore.